All right, let's talk about the next part of this, which is using percentages to describe change. Okay, we're going to talk about two types of change. The first one is going to be absolute change, which is also called absolute difference, and this is just a number. And it is just the compared value minus the reference value. Okay, so in both of these, we'll talk about that in just a second. It's just a number. Is it increasing? If it's positive, if it's decreasing, it is negative. Then we're going to look at relative change, which is also called relative difference, and this is going to be a percent. Now, to find it, you're going to have to know your absolute change. You can do it as in two steps, finding the absolute change and then doing the division, taking the absolute change divided by the reference value, or you can do it all in one formula, and we'll do both. It's given as a percent, and both of these, if it is an increase, then the change is positive. If it's a decrease, the change is negative. Okay, so let's start by looking at Lake Travis. In 2015, Lake Travis was at a historically low level of 624 feet. Luckily, the lake increased by 62 feet in the next year. Okay, so what was the lake level in 2015? Well, that's where we started. So this is going to be our reference value. This is where we start in 2015. And that level was 624 feet. What was the level in 2016? Well, we have to take the original amount, the 624, plus the 62, and that gives us a compared value of 686 feet. So what is the absolute change? It tells you how much it increased. It gives you this one in the problem. Okay, so we know it's 62 feet, but we can also find that by taking our compared value and subtracting our reference value. And we will get 62 feet. To find the relative change, we're going to take this absolute change value and divide it by our reference value, which is 624, and we end up with a decimal of 0.099 or 9.9%. Now, depending on the situation, you may want to just know what the absolute change is, or if maybe it's not meaningful to you and you want to know that it's a percent. So do you want to know that it increased 62 feet or that it increased 10%? It depends upon your situation, what you're looking for. All right, everybody loves a pay raise. Suppose your salary has increased from $30,000 up to $32,500. What is the change between the starting salary and the salary after the raise? Okay, so the starting salary is going to be our reference value, which is going to be $30,000. The salary after the raise is our compared value. That's going to be $32,500. So the absolute change, I'm going to take the compared value, $32,500, subtract the reference value, and I get an absolute change of $2,500. Now it went up, so that makes sense. To find the relative change, I'm now going to take the absolute change, divide it by the reference value. And I get, as a decimal, 0.083, which as a relative change, I'm going to change it to 8.3%. Okay, the recession hits and everyone at your work must take a pay cut. Better than losing your job, but still not the most pleasant thing in the world. Okay, so your salary drops from 32.5 down to 29. The reference value now, we're starting with the 32,500. The compared value is after the pay cut, which is 29,000. The absolute change, we still take the compared value minus the reference value. And in this situation, it's dropping, so it's going to be a negative number. And so you're losing $3,500. The relative change, we're going to take the absolute change, which is negative 3,500, divide it by our reference value, which is 32,500. As a decimal, we get negative 0.108, which means the relative change is negative 10.8%. So the $3,500 pay cut is equivalent to almost 11%. All right. Let's talk about comparisons where we have to identify what the reference and compared values are. If we're just comparing two cars, like the Mercedes, the $50,000 Mercedes and the $40,000 Lexus, we can make either one that we want as the reference value. So let's start by making the Mercedes the reference value. So if I do that now, the compared value is the Lexus. So I'm going to do 40,000, the compared value minus the reference value, which is 50,000. And I get an absolute change of negative 10,000, which means that the Lexus costs 10,000 less than the Mercedes. The relative change is negative 10,000 divided by our reference value of 50,000. And that becomes, as a decimal, negative 0.20, which means the relative change is a negative 20%, which means the Lexus costs 20% less than the Mercedes. But now let's flip that. Let's make the Lexus the reference value, which means the Mercedes is the compared value. So the absolute change is going to be the compared value, which is the Mercedes, minus the reference value, which means our absolute change is a positive $10,000, which means the Mercedes is 10,000 more than the Lexus. The relative change is going to be our absolute change divided by our compared value, our reference value, which this time is 40,000. That gives us, as a decimal, 0.25, which is 25%, which means it is 25% more than the Mercedes. Notice the changes here when we change the reference and the compared values. The absolute change goes from negative to positive, and the percents change because notice we're changing our denominator. We have to use our reference value. So it makes it really important for us to figure out which one is which. Okay, so you bought a car for $15,500 and after 6 years the car is worth $8,700. What is the reference value? Well, this is where we start. So that's going to be our reference value. Our compared value is 6 years later. It's 8,700. Okay. So to find our absolute change, we're going to take our compared value, 8,700, and subtract our reference value, 15,500. So we get an absolute change of negative 6,800, which makes sense. The value of the car is going to go down. The relative change, we're now going to take our absolute change and divide it by our reference value. And as a decimal, that gives us negative 0.4387, which gives us a negative 43.87%. All right, let's compare a couple of salaries and we can see what the difference is when we're looking at absolute versus relative change. Okay, so Mary has a salary of $100,000 and Susan earns an hourly rate of $10. Both receive a $15 raise. Okay, so our reference value is going to be the starting for each of these. So for Mary, it's going to be $100,000, and for Susan, it's going to be $10. Now here we know that they receive a $15 raise. That is our absolute value. I'm sorry, our absolute change is going to be 15. Which means our compared value now is going to be our reference value plus the absolute change. So our compared value is going to be $100,015. Here we are going to take our reference value plus our absolute change, which is going to give us a compared value of $25. So this is where the big difference comes in, is when we can start looking at our relative change. So our relative change is going to be 15, our absolute change, divided by our reference value, which gives us as a decimal 0.00015, which when I turn that into a decimal, a percent, is 0.015%. Here, to find our relative change, we take our absolute change divided by our reference value. As a decimal, that gives us 1.5. When we turn that into a percent, that becomes 150%. So who got the better raise? Susan. Got a 150% raise. Now that doesn't say who has the most money. $100,000 is more than $25 an hour unless you just work night and day. But the rate, just comparing the raise, even though the absolute values or absolute change were exactly the same, the percents were substantially different. This was a tiny, tiny insult raise. This was a real raise. Okay, we want to find on these last problems the relative difference to fill in the blank. Okay, the relative difference, of course, means we are going to find the percent. All right, the 2009 life expectancy in Canada is is 81.2 years is what percent greater than the life expectancy in Russia? Okay. In this, Canada is compared to Russia, which means that Russia is going to be our reference value. And then Canada is going to be our compared value. Now, all we want is the relative difference. So let's use the formula where we do it all as one. So our our relative difference is our compared value minus our reference value, all divided by our reference value. Now, if you want to do this in 2 steps, remember this is just our absolute difference. So when I put this in my calculator, that becomes 15.3 divided by 65.9, which gives me 0.232. Now notice in the problem it says greater than. This should be a positive number. If I turn it into a percent, this is 23.2. Okay, the median age of first marriage of U.S. women is 25.9 years. Is what percent less than the median age at first marriage of U.S. men? Okay, so the women are compared to the men, which means that the men is our reference value, and our women is going to be our compared value. Okay, so in our formula, we know that the relative difference is equal to our compared value, 27.5, whoops, 25.9, sorry about that, minus 27.5, all divided by 27.5. Now once again, if I want to do this in 2 steps, I can say this is negative 1.6 divided by 27.5. This is my absolute change. When I turn that into a decimal, this becomes negative 0.058. So less than means it is going to be, if I move this over, 5.8% less than. When I'm writing it in a sentence, technically this is a negative 5.8%, or I can say 5.8% less than. Those are all equivalent. Okay, the median age at first marriage of U.S. men is what percent more than the median age at first marriage of women? Okay, so now we're comparing men compared to women, which means our women are the reference value and the men are the compared value. So my relative difference or relative change is going to be my compared value minus my reference value divided by my reference value. So my absolute change here is positive 1.6, but my reference value has changed to 25.9. So if I do this in my calculator, 1.6 divided by 25.9, I get that my relative difference or relative change is 0.062 or 6.2% or 6.2% more than. So it's just different ways of writing it. It's all the same information. Okay, the end.